So next we're going to hear from Jacques Nadeau, who, like Julian, has a very storied open source career. He also co-created Arrow. He was on the founding team for Dremio. And most recently, I believe, he has built Substrait, and then Sundeck, which is a company on top of Substrait. I'm looking for validation. Yes, okay, great. Thank you so much for being here, Jacques, and the floor is yours. Oh, wait.
Yeah, thank. Hello, everybody. All right. So, well, I guess I should go back. So what I'm here to talk about, so Julian did a great introduction to sort of open data, the deconstructed database. I'm going to take it to sort of more of, go to more to the business side. And so what's now and what's next about open data and why it matters from the business side. So she mentioned quickly who I am. I worked on a lot of open source stuff. I worked on a few commercial things. I want to start out with a really interesting question, because it's a question that a lot of people have asked me, and I think a lot of people have curiosity about, which is, why did Databricks pay billions of dollars for Tabular, right? Like, we don't know if it's 1 or 2 or 1.5 or whatever. I don't know. I wasn't in the room. But a very big dollar amount. And so when we think about answers for this, the most natural answer is, oh, well, Tabular had a bunch of customers. They have revenue opportunity. Databricks wants to grow. And this is the normal answer that you'd give when you say, like, why did a company buy another company? Is because it's a good opportunity in the market, right? But if you actually look at Tabular and you look at Databricks and look at the differences in the revenue, you're talking about probably Databricks is probably 250 to 500 times more revenue than what Tabular had. And there wasn't a suggestion that the Tabular market itself was going to be a really large market. So it's hard to believe that that's the reason that it was the case. The second most common reason that someone buys another tech company is an acqui-hire. They're like, oh, there's some really good talent inside of that company. We should hire those guys and bring them over here, or those gals or those folks, right? Now, if you do this based on the Iceberg contributors and PMC members and committers at Tabular, I believe that there were 5 committers, maybe 3 PMC members that worked at Tabular. So if you do it on the committer level and you say it's a conservative estimate that it was a $1.5 billion acquisition, that means they paid $250 million per committer, roughly. Right? A little more than that. I would bet you, I know those guys, they're great guys, but I bet you could ask any of them, would you go and work at Databricks for $250 million? And they'd say yes. In fact, they'd probably say yes for $100 million. Like that's like that. So the idea that this is an acqui-hire, also very, very difficult to believe, because you could hire people a lot cheaper than a couple $100 million per person. Okay. So the third thing that people have hypothesized to me is it's to kill Iceberg. And this is the conspiracy theorists out there, the QAnon, if you will, which is like, hey, Iceberg was taking their business away and they were wanting Delta Lake to be successful. And so they bought Tabular, they're going to kill Iceberg now. And there's actually people who have talked about, like, hey, we should fork Iceberg because, Databricks is too involved and we should kill it, okay? This one here to me is actually the most laughable. And the reason is that Databricks, for all of their interactions with open source, positives and negatives, they have a pretty good familiarity with open source. Spark started out open source. That team saw the benefits of starting with open source, but also the challenges was they try to control the project more, okay? And they know that there's enough people working on Iceberg that if they tried to destroy the Iceberg community, it would just get forked and it'd be Iceberg 2.0, and all the people who contribute to Iceberg would just contribute to Iceberg 2.0. It might be called something else, Fooberg, whatever. And so the idea that I'd spend $1.5 billion to kill Iceberg is actually a bit laughable to me. So the next one starts to become a little bit more interesting, which is right now, there's a lot of people who are on the sidelines. They're like, I don't want to get into the VHS versus Betamax scenario, which, dates me. I know I'm talking about that scenario. And so people are not necessarily adopting Lakehouse, right? And so if you're Databricks and you want to acquire Snowflake customers, and Snowflake customers don't use Lakehouse patterns and don't use an open table format, it's much harder for me to move that workload from Snowflake to Databricks, right? And if people are holding off on adopting an open table format until there's only one, right, that it's in the best interest of companies like Databricks who want to take over other people's workloads to get that to combine. So this starts to be a little bit more interesting. What actually people don't talk that much about is that Iceberg and Delta Lake at the file level, at the actual specification level, aren't that different, right? They do implement things a little bit differently, but they're kind of converging towards the same common space. So we're starting to get into some ideas of why this might be actually making more sense. The next one, even more likely, right? I'm selling to customers. Right now, my brand is completely associated with Delta Lake. And when I go to try to sell someone and they use Iceberg and they've said, yeah, we're all in an Iceberg, it's harder for me to sell to them. Because they're like, well, you don't like Iceberg, you like Delta Lake, right? Like people mentally model Databricks and Delta Lake together, right? And so if you need to say, hey, I need to up my credibility with my customers to say, yeah, I can go in and I can sell you something and oh yeah, it's great. We work great with Iceberg, right? How better to do that than actually have a bunch of Iceberg committers on staff, have the creator of the Iceberg standard there. And then the last one that people like to talk about is to F Snowflake. And this actually sounds ridiculous, but at the same time, if you think about it, right, a lot of people look at this, especially from a perception standpoint, as a zero-sum game between Snowflake and Databricks, right? Whoever gains, the other company loses, okay? And so this is actually pretty reasonable. And so my understanding, I'm not close to this, but my understanding is that after the acquisition of Tabular, the private market valuation of Databricks went up by substantially more than the size of the cost of the actual acquisition. And at the same time, in the public market, Snowflake went down by more than that, right? And so while it may not exactly be this, it's about public perception, right? Because at the end of the day, that's kind of what market dynamics are about. So anyway, a very interesting scenario. And what it did, I think, to a lot of people is say, I wasn't really paying attention to table formats and Iceberg and all this different stuff because it's just like one of like 100 different texts I hear. And then all of a sudden you see this giant outsized spend on something and you're like, wait a minute, I need to pay attention to this. Okay, so that tells you like at the high level why I should pay attention to it. Yeah, billions of dollars, that's gonna make me care because I'm gonna go look at what's going on there. But then the other question is, but why? Like sure, there's companies are fighting each other, whatever, but does that really matter to my business? And so that's what I actually want to talk about is that why should I care about this? And it really comes down to cost. So if you think about data management, right, there are three main components to data management in terms of cost. The first is storage, the second is compute, and the third is people, right? And so if you ask yourself, oh, okay, well, what is Iceberg about? Well, Iceberg is about storage. So it must be the storage is a lot of cost. And that's why I should adopt Iceberg because it allows me to control my storage. Well, the reality is the opposite. Storage is actually the smallest fraction of total cost for most data management organizations. It doesn't mean that there aren't some out there that maybe storage is a large cost. But if you actually look at research on this, the vast majority of the spend is on compute and people. People actually outsizes everything else, typically estimated about 70% of your total data management costs. And so then the question is like, well, why is it that a storage format and changing how storage is done changes my cost? Because it seems like people is the big deal. And the reason is this. It's about siloing. It's about the fact that most systems were built monolithically. And so if I like to write Snowflake queries, well, my data better be in Snowflake. And if my data is in BigQuery and I like to write Snowflake queries, well, that sucks because I'm going to have to write BigQuery queries and use those APIs. And so what has historically been the case is wherever you store your data controls how people access it. And the reality is that when you're thinking about trying to make those people efficient, you want them to interact with the API that they're best at. So if you think about programming languages, right? Like if you take a C developer and you ask them to write Python, they're going to be able to do it. They're going to be able to do it. And maybe they'll even get excited and become Python developers, right? But initially, there's a huge amount of cost to transitioning to a different language. And the same thing exists with data, is if you are forced to use a particular system, many of those people will actually be less efficient to use that system, okay? And so you kind of have this weird combination, which is where is my data stored versus what is my most comfortable API? And the comfortable API is at a per individual data operations person, a data engineer's perspective. And so as an organization, you have historically three options. The first one is you kind of just say, you know what, we're going to focus on one system. We're going to put all our data in that system. We're only going to hire people who like to work with that system, right? And this can work if you're a smaller organization, but it also limits your ability to hire people because you're constraining yourself to one kind of interaction or API. The second option, which is probably more common, is you say, you know what, I'm just going to copy the data between multiple different systems. I'm going to say like, this group of users like to, work with Snowflake, and this group of users like to use, Pandas on their local desktop, and we're just going to copy the data around to wherever people want to use it and the paradigm that people are wanting to use it. The third one, which also happens quite a bit, is you say, you know what, we picked a system. Unfortunately, we can't hire people who are really comfortable with that system, so we're just going to force other people to work with that system, right? And so that has historically been the world that we've been in. And when you insert something like Iceberg, all of a sudden you say, okay, well, that's an option. So let me think about how different organizations work with this stuff. And so there's been two approaches to solve this. The first is what I would describe as the clone APIs approach, which is, hey, I recognize that people like different APIs. I'm going to clone those APIs to work on top of my existing storage. And so this is exactly what Snowflake has done. They launched last year at Summit, they launched PySpark compatibility layers, so you could take your PySpark programs and you could run those inside of Snowflake. And this year they launched Pandas API, cloned APIs, so you can run your Pandas. And so if you're like, I like writing Pandas code, now I can run it inside of Snowflake. The second approach to this is what Databricks did, which says, hey, let's decouple storage and let's make it so that storage is separate from what kind of API I'm using to access it. And what we've realized now, I would argue, is that, and frankly, the $1.5 billion would argue this as well, is that the decoupled storage is the stronger approach, because it's going to take forever for Snowflake to clone all of the different APIs that people like to use, and it's only going to get worse, right? There's new APIs coming out all the time. There are different ways that people like to interact with data. So this is what table formats allow us to do, is it allows us to separate out that storage so that even if I have my data stored someplace, I now can access it with different paradigms, different APIs, and that means that my users can be most comfortable in how they're interacting with data. Okay, so it's really about the efficiency of your data engineers, that the reason is that you're ultimately going to want to move towards this direction. So it doesn't matter the $1.5 billion, other than that's a signal to say, pay attention and think about how this actually can help you as an organization. Now, what's next on this? Well, here's this good news / bad news. This war is only beginning. So the first war, you saw the fight over the last couple of years. Is it Delta Lake? Is it Iceberg? The reality is that they're kind of similar. I like Iceberg better. It's a more open community, but they're technically speaking, they're kind of similar. They both work and achieve the same things. We're at the tail end of that battle, right? Like Snowflake's acceptance of Iceberg, they need to be able to respond to customers who are Iceberg all in and basically incorporate their own credibility around the Iceberg community. We're at the waning edge of the battles around data formats. It doesn't mean that there aren't others that still are arguing, oh, this is still a fight and we need to focus on it. But the reality is that there were, generally speaking, two general purpose formats, and then there were several special purpose formats. There's definitely places for special purpose formats. There's new formats coming out all of the time. Like, Hoodie's one that's been around for a long time. Lance is another one. There's several others that I can't remember. There's one that came out of Flink community that I can't remember the name of right now. So there are many new formats that are special purpose, and then there's these general purpose ones. We're at the waning edge of the general purpose ones. The thing that we're just starting in on is the catalog wars. So one of the things that people generally hadn't talked that much about in terms of the Iceberg community that was stronger than the Delta Lake community, Delta Lake had a fairly uniform, that's ironic, I wasn't trying to make a pun there, but a uniform approach to catalogs, because generally speaking, the only catalog was being created by Databricks. Iceberg, as an open community with lots of different people having different ways to approach this stuff, created lots of different catalogs. And so at one point, I think there was 12 or 14 different catalogs out there. And so there's a lot of fragmentation at the catalog level. But in the last year, right, we've seen a real consolidation of that. And really what we see is a fight between two leaders, one having been around a while. This is a Unity catalog that Databricks has that claims to support, Iceberg and Delta Lake and whatever. And the other one's Polaris, which Snowflake launched recently, which is a fairly new technology. But hey, it's one of the two gorillas, so it's probably going to get a lot of momentum, and you already start to see that in the open source community. So we're starting to see those fights. But what you have to realize is that's not the big fight. That's not the big enchilada. The enchilada is the engine, right? Because at the end of the day, if you remember that slide before, Databricks, Snowflake, and a lot of other companies, they don't make money off of the people, right? And that picture is compute and storage. They've given up storage. They are fighting over compute because that's where the revenue is. So I think at last count, I think Snowflake's revenue is 90% compute, right? And I think that Databricks is probably somewhere similar, although the numbers are not public. And so that's really where the battle is, right? And so what you may not realize, and you sort of see some pictures of this when you were looking at Julian's talk, is that, so we've been going through this maturation cycle, right? So Parquet came out a little over 10 years ago. Sorry if I'm standing in front of things here. So Parquet came out over 10 years ago. Then we had Iceberg and Delta Lake came around about 8 years ago, something like that, 7 years ago. And then Polaris and Unity came out more recently. And so we're seeing a maturation of the technologies, building up the stack to something that's not only more mature, but more accessible, right? And so having everybody have to interact with individual Parquet files took a lot of technical expertise. But if we can move it up to a much more abstract table level, then a lot more people can use that without having to know as much technical details, right? So when this has been happening, the same thing has been happening at the compute side. It's talked about a lot less because it's not as accessible right now. Like interacting with storage and being able to interact with different storage, something that makes a lot of sense to people, but it's also been happening at the compute stack level, right? And so everybody knows about Arrow. They know that some things get powered by Arrow, but a lot of people aren't writing code against Arrow because it's a low-level primitive in the same way that Parquet is kind of a low-level primitive. Not a lot of people want to write readers or writers for Parquet files, right? And so on top of that, you started to see these modular compute kernels, right? And two of the key ones that have been very successful are Data Fusion in the open source Arrow ecosystem, which is a Rust-based data kernel that's processing stuff. And then the Velox project, which came out more recently from the Meta team and is part of how they're trying to make their stack more quick. And then more recently, I've launched with some other people, launched the Substrate project, which is another level of abstraction above this. And so what you're seeing is that left-hand side, which is the storage stack, has gotten to the mature level where it's like, hey, I'm going to start to adopt that. And then the next thing you should expect is that there's going to be the same kind of competition on the right-hand side as people are trying to gather as much compute capacity as possible. And what happens to that chart that I was showing before at this point is you then see a separation at another layer in that stack, right? So right now, if you say today you're not on a table format, you're in a situation where you basically, wherever the data is stored, you're going to either have to copy the data out to use it someplace else, or you're going to have users use those APIs. We insert the table format. Now you can pick different engines to work with your data so you can actually have users use the right thing. But you're still in a bit of a negotiation challenge, right? Because if all my users like to work with the Snowflake APIs today, Snowflake knows that. And so they're not that scared about having the storage abstracted because they've done a really good job on the API side, right? But if we start to abstract the API from the compute, then all of a sudden that allows you to actually figure out, hey, where do I actually want to run this work? As opposed to just figuring out like, okay, I can run it where the API is. I now have the ability to choose an API, and I also can choose what is the compute that works within it. And so that to me is the next thing that's happening. Yes, we're going to start, we had the table wars, they're starting to tail down. We're going to have the catalog wars, and then it's about the big old, the mega battle between the engines. So that was what I had. Any questions?
Yes.
I can just repeat your question.
Yeah. In Spark, the engine was based on Python, PySpark, that was this. Some characteristics because you have multiple API across different platforms very different. So what is the really more different API like yeah.
So just to repeat the question for those that didn't hear it, he was pointing out that like depending on whatever you use at the highest level when you're interacting with Spark, whether it's Spark connectors, PySpark, or the other Java APIs or whatever, that gets converted into Scala and then that gets executed. And he was asking, what's the corollary or how does that work in the world that we're talking about with Substrate? And so I'd say two things, which is that historically that's how Spark worked, right? More recently, Spark doesn't work that way as much, right? And so if you take the Microsoft Fabric stuff, right, where they're running Spark on top of Velox. And so in the middle, it's Scala, but then at the bottom, it isn't Scala anymore. It's actually something completely different. And so what Julian talked about before is that as a operation starts at the top and moves its way through the system, it gets converted into different intermediate representations of what's happening, right? And historically, those intermediate representations, called the query plan most often, those query plans are very sort of customized to that system. They're bespoke to that system. And in order to try to move, say, a query plan from Spark to Velox, you had to come up with a common representation that you could move between the two systems because Spark doesn't expose the query plan as a public API and a serialized API that you could hand to another process, okay? And so that's actually how Substrate works. And so I don't actually know offhand whether or not Fabric uses Substrate, but the Gluten project, which is a connector project to allow you to run Spark jobs on top of Velox that's available in the open source, does use Substrate. And so the idea behind Substrate is that you have a standardized way to express what you want the compute to be, independent of where it's going to run or what language you might be writing in. And so much the same way, like Arrow represents data, and it represents data in memory across different systems. You can use different languages to interact with that memory, but it's the structure in memory that's consistent. Substrate's similar in that it's saying like, hey, let's define a way to express a processing instruction and then make it so that that's not language specific or that's not engine specific. So it becomes an intermediate representation. In much the same way, if you're familiar with LLVM, low-level virtual machine, LLVM completely changed how languages were built. It used to be that if you wanted to write a programming language, you would have to sit down and write from start to finish. You'd have to write, what is the syntax? I'm going to parse the syntax, just like Julian was talking about how you used to build databases, right? And you'd have to parse it down. You'd also have to figure out like, hey, what registers I'm going to use? What instructions am I running at assembly level to actually get this thing to run on top with the CPU? LLVM said, hey, let's introduce an intermediate representation between the front and the back. And that intermediate representation allowed people to be very creative at either end. So if I want to come up with a new language, I don't have to figure out how to run it on registers. I only have to figure out how to get it to LLVM's representation, and LLVM will do the rest of my work for me. And the same thing on the back end, right? So if I want to target a new architecture, for example, WebAssembly, if I make LLVM take its intermediate representation and figure out a way to run that on WebAssembly, now every language that works on top of LLVM now works with that. And Substrate has much the same idea, but the unit of compute is analytical compute. So you do common operations like aggregations and filtering and those kinds of things as the level of compute, as opposed to like low-level instructions for a CPU. Other questions? Oh, question over here. Go ahead.
If you could comment at Botok at Arkham, right?
Yeah. So the question was, how do you compare Photon and Data Fusion, and how do you see them evolving? And it actually is a good point on the Photon stuff. So when I was thinking about first starting the Substrate project, my hypothesis is that people were going to start to disconnect that stuff. This disconnect the front end of how you initially thought you were going to run a query versus the actual implementation, right? And so to me, Photon was a perfect example of why it would make sense to do this, because even the people who built Spark have realized that Spark is not the best way to run Spark, right? Photon is the best way to run Spark. And so the same thing actually is happening inside of Amazon, where the vast majority of people who work on data processing at Amazon are the Redshift team. And so what's happening is they're starting to try to get the EMR and the Athena stuff to use more and more of the Redshift engine. So even though you think you're using Presto in the context of Athena, you're actually using Redshift lower level stuff to do processing for the higher level stuff. And so in the context of Data Fusion and Photon, which I think was the question, like my expectation is that this will continue to mature. And so there's the biggest organizations right now run Spark on not Spark, right? They're working with Velox, they're working with Data Fusion, they're working with ClickHouse. There's a bunch of companies in China that actually have replaced the backend, the processing side of Spark with ClickHouse. And so there's a bunch of experimentation in this. And I don't believe that one has, in the open community outside of Databricks, has become the dominant form. I think that they're kind of all vying for that position, and in the open source way that things vie by just basically some form of branding and meritocracy. But I think that will consolidate, and that the way you will run Spark jobs in the future will be a fairly consolidated thing. Now, my hypothesis in the longer term is that we don't think about analytical compute right now as a commodity in the same way that we think about EC2 compute, right? Like whether I'm using EC2 or I'm using the Google equivalent or the Azure equivalent, those are kind of commodities to us. It's like, you're sure there's slight differences in the nature of the various machines, but I don't really think about the low-level details, and I don't think about that as a competitive advantage that like, oh, there's better machines on one of these compute vendors than the other. I believe that that's where analytical compute is going, because if you actually look at these things, whatever language you're using, it all kind of boils down to the same set of operations. You may embed individual business logic in Scala or Python or whatever, but the vast majority of the work is being done in a standardized form. And so I think that ultimately would be where we go. And so next step for us is going to be that there's comes to be some consolidation about what is the most common pattern to run Spark jobs on something that's not Spark. But then I think the step after that is that as that's standardized, Amazon's going to launch a service which does that thing. So that then you can target that as an alternative compute engine that's a service as opposed to having to build it yourself or self-manage it. That's my hypothesis. Cool. All right, I think my time is gone. I've got the rope coming out from me. Thanks so much, everybody.